Either. It's Professor Monty again. Let's look at an application of systems of equation looking at a distance problem. All right. So it says Lee's boat took 3 hours to travel downstream with a 6-mile-per-hour current. The trip back against the same current took 5 hours. Find the speed or the rate of the boat in still water. So there's really two things we're looking for. X is the speed or the rate of the boat. We'll say rate of boat in still water. And y is going to be the distance. They didn't tell us that either. And if you want to use s or r for the rate and d for distance, however you want to do it is fine. I like to use x and y just in general. But it's a motion problem, a distance problem. We're calling this distance. Sometimes they're called motion problems. But the key formula is rate times time equals distance. And so I'm going to do my little boxes here. We're going to get the equations just straight out of this box. Now, the first thing, he goes downstream. Downstream, and then he goes upstream. Okay, so when he goes downstream, his rate is whatever the speed of the boat would be, x, but he's got a 6-mile-per-hour current pushing him downstream or making him go faster. So downstream, let's move this box a little bit this way, we need a little more room, is going to be x, the speed of the boat in still water, plus 6. And then coming back up against it, it's going to be x minus 6. All right, the time. Oh, they just told us that. 3 hours going down, 5 hours coming back. Now, if you were doing this problem just with one variable, you would just multiply across for distance and say, oh, the distance are the same, and you set those equal. That you can do this problem pretty straightforward with one variable. We're going to use two variables. We're going to call this y. But then from these, we're going to get our equations. So it's rate times time. So I'm going to multiply these through. I'm going to distribute. And I'm going to get the answers up here so I can work out the problem. But I'm going to get 3x plus 18 equals y. Okay, equals the distance. The distance is y. This one, same idea. I'm going to multiply through 5x minus 30. And that also equals y. Same distance, same y value. Now I'm in two variables. The easy way to do this is say, hey, you know what? Since this is all equal to y, let's just plug it into the other equation for y. So we're using the idea of the substitution method. If I wanted to, say, multiply one of these equations by -1, I'd get a negative y. I could add them together and cancel the y's. It's another way to do the problem. So I'm just going to use substitution. So I plug that in there. So I've still got this 5x minus 30, but now instead of equal to y, it's equal to 3x plus 18. And now I've got my problem just in terms of x. I'm going to go ahead and solve that. I'll subtract the 3x. I get 2x minus 30 equals 18. Add the 30. And I'm doing this pretty quickly because it's just a simpler algebra. If you want to pause this and work through it and then see that we're doing it the same way, fantastic. 2x equals 48, and then just divide both sides by 2. X equals 24. And that's my answer. Remember, what's the question? Find the speed or the rate of the boat in still water. Well, x was the speed of the boat in still water, so that's my answer, 24 miles per hour. If I wanted to find what the distance was, that's why I could either plug the x in here or here. They both have to give me the same answer because they're both y. I don't care what y is because they didn't ask, but I could find it easily if they did. Okay, so practice these. I love setting up the box with the rate times time equals distance. It helps me a lot in getting to the equation.